Hello guys. Today we talk about lipid metabolism, and we start metabolism by how we can produce fatty acid in our body. I know that everyone knows that lipid or fat like fatty acid and glycerol. Here is the main points where we can create kind of lipid or fats. But what I would like you remember that we have something called essential fatty acid and essential amino acid. Once we say essential, we mean that the fatty acid which our body cannot produce it. So not all the fatty acid our body can make it, but we need to get some of them by diet. And the fatty acid what we can get by diet, it is the fatty acid called two essential fatty acid, linoleic acid and alpha linolenic acid. Linoleic acid, it is a base to form arachidonic acid, and this arachidonic acid is very important as a substrate to produce prostaglandin. And alpha linolenic acid, it is very important to the process of growth and development and so on. So generally here is the two essential fatty acid. Other fatty acid we can produce them. So fatty acid synthesis or production of fatty acid synthesis primarily happen in the liver, mainly in liver and mammary gland, and we can say lesser extent in adipose tissues. يعني mainly we produce fatty acid in liver. Then this fatty acid are traveling from liver to go to be deposit to add it into the adipose tissue. But also we can produce fatty acid in adipose tissues. And please remember, this process is cytoplasmic process. It is cytoplasmic process. Here is the introduction, what we're talking. Then I go here, and I'm sure you remember this figure before. And you know that here you are talking about carbohydrate pathways. What related between this pathway and fatty acid synthesis? Look guys, we don't have separate rooms in our body, one room for carbohydrate, one room for lipid, one room, no. So what happened exactly is everything is related. Now I produce fatty acid. Let me asking you, what time you can start to produce fatty acid? We produce fatty acid when you are in starvation, for example? No, we start to produce fatty acid in feed state. We produce fatty acid when we have high blood glucose. Because when you have high blood glucose, you will increase the insulin. يعني insulin itself will increase the transcription of the fatty acid synthase enzyme. يعني insulin increase fatty acid synthase transcription or transcription and translation in gene expression. We produce fatty acid when we have high ATP. يعني ATP itself, when you have too much energy, you start to make fatty acid. So here is the situation or the cases or conditions when our body will direct its pathway to produce fatty acid. Generally, you remember with me, we said that when we have a glucose, here is the glucose. Glucose are transported inside the cell, for example, liver, GLUT2. That glucose are transporting inside the cell, converting to glucose 6-phosphate. And that glucose 6-phosphate, fructose 6-phosphate, fructose 1,6-bisphosphate, glyceraldehyde 3-phosphate, DHAP, and so on. This pathway is called glycolysis to produce pyruvic acid. So we have here pyruvic acid. Let me make it smaller. It says pyruvic. 2 pyruvate. Okay, that pyruvate will go where? By pyruvate dehydrogenase complex converted to acetyl coenzyme E. I'm not explaining glycolysis or carbohydrate pathway again, but we should know this. So you have glucose produced by aerobic acetyl coenzyme A. Acetyl coenzyme A is 2 carbon. Acetyl coenzyme A plus oxaloacetate will give citrate. Citrate will convert it to isocitrate. Isocitrate converted to alpha ketoglutarate by isocitrate dehydrogenase. Alpha ketoglutarate converted to succinyl coenzyme A. Here we produce ATP, GTP, ATP. Just a moment. So if I eat too much glucose, I produce too much ATP. Logic or no? Yes, man. You eat one chocolate, you have too much ATP. What happened now? We have allosteric inhibition for that ATP to inhibit the isocitrate dehydrogenase. So the ATP itself will block that enzyme. So what happened now? I will accumulate isocitrate, but isocitrate to citrate it is reversible. So isocitrate can convert it to citrate. Okay, so citrate is accumulated. So now we have accumulation for the citrate. I hope I'm clear. We have accumulation for the citrate. What happened now if you have accumulation for citrate? What happened now? Citrate is accumulated and this will say, I hear some of you, citrate convert to acetyl coenzyme. No. So we have accumulation of citrate now. The question is, if you accumulate citrate like this, and I'm telling you that the most important molecule to form fatty acid is acetyl coenzyme A. So the point is, I will convert this citrate again to acetyl coenzyme A and oxaloacetate, but that conversion not happen in the matrix. So we need to transport that citrate out of the matrix to cytoplasm. So I get that citrate from here to here. This transporting of citrate is called what? Citrate shuttle. Pyruvate transporter citrate shuttle. So pyruvate transport here to make acetyl coenzyme A. Then acetyl coenzyme A convert to citrate, accumulate citrate, I citrate outside. So I send here what? I send here citrate. What is my target? I need to get acetyl coenzyme A in cytoplasm, not in matrix. So I need to convert citrate again to its a component. Citrate coming from where? Coming from acetyl coenzyme A and the oxaloacetate. So I need to convert the citrate again to acetyl coenzyme A and oxaloacetate. So we need here what? We need one enzyme which is able to convert the citrate or hydrolyze citrate to acetyl-CoA and oxaloacetate. That enzyme is called what, guys? That enzyme is called ATP citrate lyase. ATP citrate lyase. You understand what does mean lyase now? Hydrolyze. So what do you expect also? I expect that I will use 1 ATP to be hydrolyzed to ADP. Let me write it here. ATP hydrolyzed to ADP. So that enzyme founded where? In cytoplasm. That enzyme function is what? Hydrolyze citrate to acetyl coenzyme A and oxaloacetate. I hope I'm clear, guys. So now we have acetyl coenzyme A. Just I need to write it in good way for you. So we have here acetyl coenzyme A. Let me straight it. Acetyl coenzyme A. And we have oxaloacetate. That oxaloacetate can convert it back to malic acid. You remember the last step in citric acid, malic acid converted to oxaloacetate by malic acid dehydrogenase. يعني I make a oxidation for malic to oxaloacetate. So oxaloacetate will reduced to malic acid. Yes, to malic acid. What is the name of the enzyme who can do this step? It is malic acid dehydrogenase. In that time we make a reduction, so we'll use NADH to convert it to AD. So we did what? We did reduction for oxaloacetate to convert it to malic acid or malate. This malic acid will convert it to pyruvate. So the malic acid itself will convert to pyruvate like this way. The name of the enzyme who can convert malic acid to pyruvate is called malic enzyme. Malic enzyme. You think this process is oxidation or reduction? It is oxidation. And malic acid is 4 carbon while pyruvate is 3 carbon. So we need to make a decarboxylation. So it is oxidation and decarboxylation. Oxidation means what? I will make a reduction for NADP. Remember? This one will convert it to, let me use the same color, NADPH. Okay, so we did a reduction for NADB to NADBH, and we'll do decarboxylation by getting out of malic CO2. So what I did now, I just bring citrate out of matrix to add it in cytosol by ATP citrate lyase, and using 1 ATP I convert the citrate to acetyl coenzyme A and oxaloacetate. But I missed something here. Guys, is citrate has acetyl coenzyme A? No. Why? Because when you make acetyl coenzyme A plus oxaloacetate, you will get out coenzyme A here in matrix. So you need to add with that reaction acetyl coenzyme A. So what we do here, we inserted here coenzyme A. You know, usually it is SH coenzyme A. So I inserted coenzyme A plus ATP citrate lyase, convert the citrate to acetyl coenzyme A and oxaloacetate. Oxaloacetate will be reduced by NADH to NAD to give malic acid. Malic acid will be oxidized by reduction, by make a reduction for NADB to NADBH, and also decarboxylation because malic is 4, pyruvate is 3 carbon. Here we have acetyl coenzyme A into the cytosol. We are happy for this. So this step, what I explained to you, simply I bring out from the matrix to the cytosol acetyl coenzyme A. Acetyl coenzyme A. Let's say what happened after this. Look, before we forget, acetyl coenzyme is how many carbon, guys? How many carbon? You remember? It's 2 carbon, yes? 2 carbon. So we have here C, double bond O, bind with sulfur group of acetyl coenzyme A, and so on. I'm sorry, coenzyme A. Okay, so here we have this acetyl coenzyme A. We have one of the most important step. That step is created by a specific enzyme, and that enzyme, what I can write it here, is called acetyl. Let me using different color. It is acetyl CoA carboxylase. What's up? Where? Yes. Carboxylase. Let me get this a little bit longer. Okay, so acetyl coenzyme A carboxylase. We mentioned something called carboxylase before. You remember where is it? It is pyruvate carboxylase, which used to convert the pyruvate to oxaloacetate. You remember this one? It's called the pyruvate carboxylase. And this pyruvate carboxylase and the acetyl coenzyme A carboxylase, we call for that enzyme, it is ABC enzyme. ABC enzyme. What does mean enzyme? Any carboxylase enzyme will need ATP to do its work. So I need ATP to hydrolyze to ADP. And also I will insert inside the reaction CO2, and it needs butane. It needs butane. And look guys, this enzyme is very important. Look for this one. It is A because ATP, B needs butane, C CO2. So that enzyme will convert acetyl coenzyme A, which has 2 carbon. 2 molecule has how many carbon? 3 carbon. 2 carbon plus CO2 will give us 3 carbon molecule. It's called the malonyl CoA. That malonyl CoA, how many carbon? It is 3 carbon. Let's draw it here, the same color. It is HO bind with C double bond O, C H2, and bind with C double bond O, bind with sulfur of coenzyme A. So here is the malonyl coenzyme A. So now in cytoplasm we have acetyl coenzyme A converted to malonyl coenzyme A by helping of acetyl coenzyme A carboxylase. That acetyl coenzyme A carboxylase, it is the rate limiting step. يعني this guy, it is the rate limiting step. Remember this one. What does mean rate limiting? Rate limiting step, it means it is highly regulated. It means if I stop that enzyme, that pathway is stopped. If I activate that enzyme, this pathway is activated. I will talk about the activation and the inhibition of that enzyme, but after I finish. But very fast, please remember this enzyme is activated by, it's activated by citrate. يعني citrate, that citrate, when accumulate citrate, I activate this enzyme. When I accumulate citrate, I activate this pathway. When I have too much ATP, I stop that process. Citrate is more. Citrate coming, that citrate will activate that enzyme to convert and producing fatty acid. And also it's activated when it is dephosphorylated. Dephosphorylated. While it's inhibited by long chain fatty acid. Long chain fatty acid with coenzyme A. يعني it's inhibited by the production of that process. We do what? We do fatty acid synthesis. We producing fatty acid. So the production of that process, the long chain fatty acid coenzyme A will inhibit that enzyme. And also it's inhibited when it is phosphorylated. يعني it's activated by insulin and inhibited by glucagon and even epinephrine and norepinephrine. Okay, now we produce malonyl coenzyme A. So we have in cytoplasm now acetyl coenzyme A and we have malonyl coenzyme A. We have this two. We now talking about very important enzyme. What is the very important enzyme? Let me get this one out here. Yani maybe you can get this to have a space. Yani something. Yes, so we can remove this from here now to have a space here. And I'm sorry for this. Okay, so even remove this butene. So now we have to think about what kind of enzyme will help us to produce fatty acid. We discovered there is a big enzyme. You know, this big enzyme contains many other enzymes. I show you one slide in your lecture. The slide in your lecture, guys, here. Here is, all of this is one enzyme. That enzyme, what I showed, it's called what? It's called the ATP synthase. Fatty acid synthase. So that enzyme is called fatty acid synthase. That fatty acid synthase from 7 subunits. from 7 subunit. If I explain the 7 subunit before I go for the process, you will lost. So let's say that we have a specific enzyme called like this one. I will talk about everyone. You know the function of subunit. Fatty acid synthase has two places. One place is called acyl carrier protein. One place is called acyl carrier protein. That acyl carrier protein is binding with 4-phosphobentothionein. يعني ACB bind with 4-phosphobentothionein, which is vitamin B5. Okay, so in that enzyme we have one place is called ACB. ACB bind with 4-phosphobentothionein. Nice. And this 4-phosphobentothionein has sulfhydryl group SH. The other center in that enzyme is called cysteine center. That cysteine center is contained also. It contains also HS or sulfhydryl. So I hope I'm clear. So we have acyl carrier protein, and this acyl carrier protein has 4-phosphobentothionein, which is vitamin B5, and the other center is called cysteine, and this cysteine has sulfhydryl. So ACB bind with phosphobentothionein. We can write this phosphobentothionein like this, guys. We can write in your lecture panthine like this one. Okay, so let me get copy of that enzyme. So we have that enzyme. I get it copy. I come here. So I have my enzyme is here. I add it here. Of course, we need it very small like this one. So here is the enzyme, and even we can make it little bit, some change to make it clear when you study. You know what is the structure of enzyme? I'm sorry, I just wanted to remove this one to add to you. This subunit is called band. So just to remember, banthine, and which is bind with SH group, and cysteine, which bind with SH group. That enzyme where in cytosol. That enzyme will come in cytosol and will make a link. That enzyme will make a link, or will get the acetyl coenzyme A to bind with that enzyme. So we need one enzyme to transfer acetyl coenzyme A to add it here. So the enzyme which can make this transporting of acetyl coenzyme A from cytosol to add it to the band side is called acetyl transilase. Acetyl transacylase. So what happened now? It will bring this acetyl coenzyme A, but also it will kick out the coenzyme A. So I lose coenzyme here. So I have what? I have only the acetyl group. So I don't have this. So I get this part, which is I will make a link here where in the band. So first of all, I will make a link with the band, disulfide bridge. So this is bind with carbon double bond O will bind with the carbon H3. So that group is called what, guys? That group is called what? Acetate group. So we have acetate group which has 2 carbon. Acetate group has 2 carbon. So here is our acetate group. Bind where, guys? Bind with the band side of ABC. But is not staying here long time. I need to transfer that acetate group from the band center to cysteine center. From the band center to cysteine center. So what I should do, I just get the enzyme in front of you, and I will get a copy here to show you what happened exactly. Look guys, here we have, so I will just remove this link, sorry, not this one. I will remove this link and I will get this acetyl group to add it here. So this one will be reduced again, and this one will be make disulfide bridge again. So here what we did, look, I hope I'm clear, huh? Everything I'm clear in front of you, because I would like to draw the figure in front of you because you will remember. I know it takes long time, but يعني here is the best way to study this pathway. It is transfer acetate to cysteine. So I transfer acetate to the cysteine. So it is called activated acyl group. Now we have activated acyl group. I hope I'm clear. So what we did now, we just get the acetyl group from cytoplasm, we add it into the band center of the enzyme in the ACP part, and then I transfer the acetate from the band ABC center to cysteine center. And we're using here the disulfide bridge which can be reduced. Okay, here is this pathway. Let's say just getting this a little bit here. Something like this. Okay, so in the same time that enzyme, our friend are coming here. Not this one, I just remove this one. We have the enzyme which has band with SH. You remember? Here is our enzyme. That enzyme will come to bind with malonyl coenzyme A. يعني the malonyl coenzyme A will transport it for the enzyme. So that malonyl will transport it like this one. I have malonyl coenzyme A which come to bind here, bind to the band center, to the ABC. So what I should do, I will also kick out the coenzyme A. The enzyme which can add malonyl coenzyme A to ACB is called malonyl transacylase. The same. Here is acetyl transacylase, here is malonyl transacylase. Malonyl transacylase. So this malonyl transacylase transport the malonyl coenzyme A, kicking out coenzyme A, and add the malonyl where? In the band center. How we add? We have here sulfur. Yes, which will make a disulfide bridge with other sulfur of the malonyl. You can see here. Then we have this structure. How many carbon? 3. The 3 carbon of malonyl, I will have them like this one. So we have C double bond O, we have C H2, we have C double bond O, we have OH. يعني the structure is not important for you, but just I need to make everyone remember what we are talking. So here we have the enzyme which bind with malonyl. The enzyme which bind with malonyl is called malonyl ACB malonate. ACB malonate. So here is the enzyme, and we have that form of that enzyme like this one. Okay, so guys, malonyl bind where? Bind with ACB, while the acetyl bind where? Bind with cysteine. Now we have malonyl in band and acetyl in cysteine. What do you think if we make a condensation for both of them? What does mean condensation? يعني I will make a reaction to bring that two form of enzyme together. يعني I will simply I will add this acetyl with the malonyl in ACB. So simply I will transfer this acetyl from cysteine center to add it with malonyl in the ACB center while I'm losing carbon. So I will do two reactions here, not one reaction. One reaction is called the condensation, because I will condense this acetyl coenzyme, this acetyl active acetyl group. I will condense this active acetyl group into the ACB center. So what I'm doing here is like this, guys. Look, I will have this condensation. So that reaction is called condensation reaction. Condensation plus decarboxylation. So condensation plus decarboxylation. Condensation plus decarboxylation. What do you think, guys? I will just in front of you, I will get this guy, which is ACB malonate. I add it here. And you will tell me what happened exactly. You remember the CO2, what we added here into acetyl coenzyme A to give malonyl? Yes, I will remove it from here. يعني the CO2 which added at the first step will be removed here, decarboxylase. So don't forget we are kicking out CO2. It's very important. And also because there are two enzymes, I will kick also out one enzyme, which is ACBSH. يعني because I have two enzymes and I just add this acetate group in one enzyme, in the other one. So I'm producing one free enzyme which will go to continue, make a cycle, and producing CO2. So what I should do here, guys, simply, you will have to remove, look, I will have this one, I remove this, and I will add the acetate, which is C double bond O CH3. So how many carbon now we have? We have 4 carbon, but 2 of them are ketone bodies. So we have the ACB bind with 4 carbon, 2 of them are keto group. I said bodies is a different topic. Ketone group. Okay, that form of production or that form of molecule called acetoacetyl is called acetoacetyl ACB. Sometimes we call it ketoacyl ACB. Ketoacyl ACB. So after I form ketoacyl ACB, I will go for the coming step. We're still not producing fatty acid. I will do some reaction for this ketoacyl ACB. This will be the second part of that lecture.